everyone. Today's lesson is on cofunction identities for Algebra 2 Trig Advanced. So let's get started. Just our goals, review our sum and difference identities, learn the cofunction identities, and we're actually not going to learn these today. Double identities will be next time I see you. Higher mathematics standards is related to the Common Core. These are listed in the Common Core standards. So just so you know, these are very, very important things that we need to learn. So reviewing, a little bit of review is going to start with some of our trig identities that we had, and this was an expansion for a sum and difference identity. And so remember, if it's sine, cosine, and you're adding, this is going to collapse into sine of 37. Sine has the same value, so plus 23. And so that is going to equal to sine of 37 plus 23 is going to be sine of 60. And sine of 60 degrees is going to equal root 3 over 2. This one right here goes cosine, cosine. Well, that's going to break down into cosine. 83 minus 53, because if it's plus here, this will be the opposite. That's going to reduce into cosine of, 30 degrees. And cosine of 30 degrees is also root 3 over 2. This one is going to break down into tangent because it's plus here. It'll be 20 plus 32. That's going to equal tangent of 52 degrees, and that's not a special right triangle or special right angle. So we're not going to be using that special angle in our right triangle trigonometry section. So it does not going to give us an exact value. So we're done with that. The next problem here, this one right here, see where it says tangent of A plus B? Now we did that expansion, right? We did this, we know this. This is tangent of A plus tangent of B all over 1 minus tangent of A times tangent of B. And we can work that out, but just a side note, you can also figure this out by sine of A plus B like this over cosine, because tangent is sine over cosine. So this expands to that. And so just so you know, that's what that's going to be. Oh boy. And this is just the proof of that. So you can take some time and look at that if you like. A couple of other things. Let's see. This one is expanding our warm-up. Expand cosine of A minus B given this. Now, this is a little bit different than what we've done so far in that I'm not giving you an actual value. I'm giving you these values, which you are going to have to redraw these in the first quadrant. So what I'm telling you is, so let's start with this. For the A graph, okay, here's A, and it says it's in the first quadrant. Sine is opposite over hypotenuse. So this looks like a 3, 4, 5 triangle. In addition to that, I have another one for angle B, okay? And so here's angle B, and B, sine, opposite over hypotenuse. So that's like that. And this is also a 3, 4, 5, but the numbers are different. Okay. Expanding cosine of A minus B. Remember cosine goes cosine A, cosine B. And if this is minus, this will be a plus, and it's going to go sine of A, sine of B. Okay, and so what this does is it says, well, cosine of A, here's A. So you're going to take this value here from here. So cosine of A is adjacent over hypotenuse. So this value right here is 4/5. Cosine of B, I'm going to come over here, and that's going to be 3/5. Okay, plus sine of A. Sine of A is opposite over hypotenuse, so that's going to be 3 over 5. And sine of B, opposite over hypotenuse, so that'll be 4 over 5. So multiplying numerators with denominators, I end up getting 4 times 3, which is 12, over 25, plus 12 over 25, and that's going to be 24 over 25. So that's my answer. That's kind of cool. Okay, cofunction identities. These are, remember these, we did these as, let's say, sine of 30 degrees is equal to the same thing as cosine of 60 degrees. So those are cofunctions. So what we're going to start with, this suggests that you use Desmos and that you type these into your calculator or into Desmos, and you're asking yourself, how are you going to translate y equals sine of x into y equals cosine of x? And how are you going to translate cosine of x so that it's the same as sine of x? So if you graph these two, you're going to get this. And if I were to, let's just draw on this, okay? If I were to do this and just sort of trace my sine wave, all right, what they're asking is what am I doing? How am I going to make my sine wave look like my cosine wave? I want this to be here. How am I going to do that? And so if you look at it, this is my sine wave. What if I took my sine wave, see it's starting at 0 here? What if I took my sine wave and I went this way? What if I took it this way, left pi over 2? What if I did that? What would that look like? Sine of, let's say this is in radians, so we're going to go x plus pi over 2. Well, if I did that and I moved my sine wave, whoops, here it is, and I moved my sine wave this way, what would it equal? What would it equal? And if you say, well, that's going to equal cosine of x, you'd be right. Okay, so that's what we're doing. These are cofunctions, but they're cofunctions with identities. Remember this? We did this the other day. This is a sum. So we're going to explore this a little bit and see where we get. Okay, so the first one says we're going to start with x plus pi over 2. And so that's a sine wave. Remember, we just talked about that. And so my sine wave, normal sine waves start at 0, go through pi, end at 0. We go up 1, we go down 1, and we end here. Now, if I were to do this x plus pi over 2, what that's going to do, there's pi over 2, is this is going to move this way, okay? And in doing that, I get cosine of x. Now, what that is an identity, okay? And it's a cofunction. So it's called a cofunction identity. And if I want to prove that, all I have to do is expand that, and I'm going to prove it. Let's prove it. Remember our sine sum and difference formulas? Remember sine goes sine, cosine, where sine is the same sign. So this is going to say sine of x, cosine of pi over 2, plus here. So that'll be that'll be a plus. And then we already used x, so now I'm going to use sine of pi over 2, and I'm going to use cosine of x. Now, in doing this, remember, sine has the same sign, so both plus, okay? You can't do anything with sine of x, but you can simplify this value right here. So we're going to say that's sine of x times cosine of pi over 2. Well, what is that? If you remember your graph, pi over 2 is up here, right? That's 0, 1. Well, that's 0. And if you don't do it that way, you also could make a little graph, and you could say, well, here's my graph of cosine. Where is cosine at pi over 2? There, it's a 0 still. So this is sine of x times this right here, which we just did twice, and that's 0, all right, plus sine of pi over 2. Well, here's pi over 2. What's sine? Well, it's 1. So that's 1 times cosine of x. Well, 0 times anything is 0. So this is gone. And now all I have left, I have 0 plus cosine of x, which is just cosine of x. And therefore, by moving this, right, we just proved that sine of x plus pi over 2 is equal to cosine of x. So cool. Okay, all right. So let's do this again. So what we have here is sine of x minus pi over 2. So I'm going to redraw my sine graph. And sine does this. Okay. And then from there, from here, we have sine of x minus pi over 2. So what we're going to do here is this says plus pi over 2. So that means that pi over 2 is here. Okay. So let's see. And I'm going to actually continue my sine wave and see what that, okay, so like that. So if I move my sine wave to the right pi over 2, so now it's, there, and this has got to continue at that. Now what does that look like? That looks like to me a negative cosine wave, right? Starts low, ends low. So I want to prove that. And so in order to prove that, we're going to expand this and we're going to get sine of x cosine of pi over 2. This negative sign has nothing to do with this part right here. It's only going to be the same sign in the middle. Don't try to, a lot of kids try to distribute. Don't do that. Okay, so then we have sine of pi over 2 and cosine of x. And so, well, we know cosine of pi over 2, remember, okay, cosine pi over 2 is 0. So this is sine of x times 0 minus sine of pi over 2. Now sine of pi over 2, if this is my graph sine, goes like this, right? Pi over 2 is 1. So this is 1 times cosine of x. So we have 0 minus cosine of x, which is negative cosine of x. So therefore, sine of x minus pi over 2 is equal to negative cosine of x. So we just proved this cofunction. Okay, that's amazing. So there are all of these really super cool cofunction identities. And you can write them like this. You can write them like this. You can prove any of them. And a lot of people will do these and they'll look at the cotangent ones or they'll look at the cosecant ones like this. And they'll be like, well, I don't know how to prove that one. Well, cosecant's the reciprocal of sine. So really for this one, right, for this one right here to prove that one, I would prove it like this. And I would say, well, that's 1 over sine of pi over 2 minus theta. And I would do the entire proof like this, okay? And, well, let's just do it, okay? What else we got to do? And so that would be sine of pi over 2, cosine of theta, and then we'd go minus, minus, and then we'd say, well, sine of theta, cosine of pi over 2, and then we'd say, well, that's going to be 1 over, now sine of pi over 2, remember, pi over 2 is up here, so that's 0, 1, that's 1, times cosine is cosine, and then this is going to be minus sine of theta times 0, and so that's just cosine, so 1 over cosine of theta, which is equal to secant of theta. So you see how I did that one with the cosecant? I just said that that was 1 over that, okay? Any of these can be proved. So again, this is the cosine one, and the cosine basically is done the same way a sine wave would be, and cosine starts high and then is ending high, and halfway in between we have a low point. Then we have these values that go in between. So this is going to look like this. Okay. And if we were to take cosine, the plus means we're going to move it to the left, right? And so, I mean, the left, not right, but left. And if I were to move it pi over 2, which is here, okay, if I were moving it that far, what that does is this. Now look at this. See this graph? See now my sine wave goes down, and therefore that's where the minus sign comes from, okay? Likewise for this one, lots of emails. Okay, cosine starts high, ends high, halfway between is low. halfway in between, it's crossing, so it's going to look like this, okay? And then again, if I were to go to the right pi over 2, which is here, so if I went to the right here, I would need to continue this on. See how I have to continue this on? Well, look at that. What kind of a graph is that? It's a sine wave. And again, I can prove any one of these, okay? I can prove any one. And a matter of fact, here you go. So cosine, remember it goes cosine, cosine. So cosine of x, cosine of pi over 2, and cosine has the opposite sign. Sine has the same sign. So this will be sine of x, sine of pi over 2. So cosine, remember, pi over 2 up here. 0, 1, cosine goes first. So this is 0. So we have cosine of x times 0 minus sine of x times 1. So this is 0 minus sine of x, which equals negative sine x. Okay? And that's going to equal cosine of x plus pi over 2. So these are going to be equal like that. This one right here is going to be, let's see here, cosine of x, sine of pi over 2, opposite signs. So that's minus, this is plus. And then you have, oh, that's not right. Excuse me, I'm so sorry. Cosine goes cosine, cosine. So that's cosine of x, cosine of pi over 2, and there's my minus sign. So that's going to be now plus. Then it goes sine of x, and then sine of pi over 2. And just really be careful that you don't distribute. Don't distribute. This might, it's very easy to want to distribute. Don't do it. Okay. And so what we have now is cosine of pi over 2. We know that's 0. So we have cosine of x times 0 is 0 plus sine of x times 1. And so that's going to equal 0 plus sine of x, which is equal to sine of x. So cosine of x minus pi over 2 is equal to sine of x. Okay, and so those are done. All right, cool. These are just more cofunction identities. And so you can memorize these, or like I said, I like drawing them. I like drawing these and just kind of looking at them and okay, which one is which? So for me, I'm more visual. I like to draw this. So like if I take this sine wave and I were to go to the left, pi over 2, now I have a cosine wave, and it's a positive cosine wave. So that one right here would be this one, check. So I'm just saying you can graph them if that's easier for you to prove, and then you prove it just to make sure, because it is a proof. It's not teaching you anything new. It's just proving what you already know. So if moving your graphs left to right, etc., is going to help you, then do that. Absolutely. Like this one right here, this is a cosine wave. And if I were to take my cosine wave like this, my sinusoid, all right, and I'm like, okay, well, what if I took this cosine wave, let me go here, and I moved it to the right? If I move that to the right, and this is this one right here, now I have a sine wave, okay? And if I took this cosine and I moved it to the left, now I have a negative sine wave. See, that's this one right here. So you just have to look, and sometimes I think graphing these is just a lot better just to see what you're doing. But you will have to prove them on the quiz and test, so just make sure that you do know how to do that. Okay. These are two other identities, and these two identities are just asking you to prove it again. So for this one right here, this is a tangent. Oh, and I think also, just for a heads up, I could do this too. X plus pi over 2 divided by cosine of x plus pi over 2. Don't forget that, because this is an option. Because if you forget the tangent formula on the test or quiz, you can always use sine and cosine. And I feel like we've done the sine and cosine enough that hopefully that you would be able to, reiterate that. But let's just do tangent right now. So tangent, so if for this problem right here, and just keep in mind, what are we going to get? Remember, this is plus and plus. So just thinking, we'll check this in a minute. So this is going to be tangent of x. plus tangent of pi over 2 divided by 1 minus tangent of x times tangent of pi over 2. Now, let's talk about pi over 2, okay? Now, we know that's up here, and this is our unit circle. We know that point is 0, 1. We know that cosine is 0. We know sine is 1. But tangent is sine over cosine. So look, check this out. 1 over 0. So what's going to happen with this? If sine of pi, x plus pi over 2, right? So if this value here, this tangent of pi over 2, that doesn't exist, does it? That's undefined. So what actually is going to happen with my graph? Okay, so if you're not sure at this point, you could always do with the sign and say, well, what does that mean? What is sine of x plus 2? So if I did that one, that's going to be sine of x, cosine of pi over 2, sine is the same, plus sine of pi over 2, cosine of x, cosine of pi over 2 is 0. So this one right here would be gone, and I'd be left with cosine of x. So this here is equal to cosine of x over, now this one right here, okay, this is all over this, which is cosine of x, cosine of pi over 2, opposite sign, so that's minus, sine of x, sine of pi over 2. Now, sine of pi over 2 is 1. So this value here is 1. 1 times this is negative sine of x. This is 0, so that's gone. So I have cosine of x divided by negative sine of x, okay? And so what that's telling me is that's a negative cotangent graph. So see here, this value, that's going to equal negative cotangent of x. So if you look at this, and we went back, I'm not quite sure how many slides back it was, tangent of, now this is backwards. This is saying pi over 2 minus theta. But if I went theta minus pi over 2, then what I'm going to do is I'm going to get a negative value. So you can do these different ways, and there's so many different ways to do them. But just kind of play around with that, and then try different variations. This one, the way I would do this one is just this way. 1 over cosine of x minus pi over 2. That's how I would do that for secant. And I would say, well, that's 1 over, and that's going to be cosine to cosine. So that's going to be cosine of x, cosine of pi over 2, minus becomes plus, sine of x, sine of pi over 2. And so that's going to be 1 over cosine of pi over 2 is 0. That's gone. This is 1. 1 times sine is sine. So 1 over sine of x is cosecant of x. Okay. So you see, I mean, you can have some fun with this, and you can prove any of them. All right. So that's neat. Okay. Well, that's all I have for you today for cofunctions. So if you don't mind, start your homework packet and also the Math Excels online, and those are due this weekend. So do your best. If you have any problems, email me, and I'll see you when I get back. All right, thanks for watching.